We're going to start again by looking at three concepts. One is new, two are old. As you know, I always like to make connections so we remember stuff easier. Yes, tables, but not that one, a very easy one. No more complicated tables. We're done with that for now, till we start reviewing for the final exam. So we know two concepts from this course. One is called the derivative, which is the slope of the tangent line to the graph of the function at that point. It's the rate of change of the function at the point where it's differentiable, and so on and so forth. We know what this is. We also know the second concept, differential. And now we're going to study a new concept in a minute. I am going to choose, this time I'm going to choose first a very simple function. So I'm going to say that f of x equals x to the third. And I will ask quickly, can anyone give us the derivative? The notation for the derivative is f prime. Of course, it's also dy over dx. They mean the same thing. Can anyone differentiate this simple function so I can put them here?
3x squared. 3x squared.
Thank you very much. Of course, everyone knows that. Now, for the same function, I would like to determine the differential. Can anyone give us the differential? They're not the same. We know that for a long time. We've been knowing. And
3x squared dx.
Very good. Thank you very much. 3x squared dx. Perfect. Okay, now the new concept that we're going to study today, and this is 4.9, entitled antiderivative. That's the title of 4.9. So this is what I'm going to put here. Antiderivative, and I'm going to write it and then calculate it. The antiderivative basically, there are two concepts in here. One called the most general antiderivative. And the second concept is specific, or one antiderivative. Is there a difference? Yes, there is a difference. This one will give us a family of functions whose derivative is this. And you can say, wait a minute, wait a minute, wait a minute. You gave us a function, you asked us to find the derivative, you asked us to find the differential. Now you're talking about something else. Yes, I'm talking about functions whose derivative is x to the third. This is what the antiderivative means. By the most general antiderivative, we will determine all possible functions whose derivative is this function, or we can be asked to determine a specific one. But this one, we are given a condition. Given an initial condition. Oh. Okay, so we're going to look at both. We're going to create a specific condition, but first let's look at the most general antiderivative and how do I determine that? And then I will give you the rule. So these are closed here. There is nothing else I can say about the derivative and the differential, but we are going to continue our discussion on the derivative. Why do I want to have them together? It's because I want you to understand the difference between the three concepts. Okay? What will be the most general antiderivative? Will be a function, since this is given as f of x, the notation will be uppercase f of x. So what is this again? The most general antiderivative. Okay, so how do I find that? And then I'll explain the rule. We are still talking about this simple function. So again, what does this mean? It means that f prime of x has to give us f of x. You can say, now you're going backwards. Yes, I'm going backwards. It's true. So if this is the distance function, this will be the velocity, right? But now I'm given the velocity as so to speak, and I want to determine the distance. I am going backwards this time. So how did I get all this? Well, knowing that if I differentiate this, I will get that. How do I know? Okay, so let's differentiate. 4, which will simplify with 4. Subtract 1 from the power. I get x to the third. Differentiate the constant. I get 0. And I get back that function. So notice that the most general antiderivative has to have a constant. We prefer to call it c. Now, if the function has its cost, I will not use c, I will use d. It doesn't matter. If you don't like c, use any letter from the beginning of the alphabet, but not x, of course. So, but we like to use c. Again, if I have the cost, I will not always use the cost and c because c and c will crash. If I have the distance, I will not use d, right? So the two letters don't crash. So there is no confusion. So this is the most general antiderivative. What is this again? A family of functions with the same derivative, which is x to the third. Now, how will I determine a specific one? I have to be given conditions from the beginning. So let's say I'm given a point. Let's say 1, 1. When x is 1, y is 1. Or I may be given anything, really, it doesn't matter. But a specific antiderivative will be when we determine c. Let's say if c equals, give me any number for c.
3.
3. Then a specific antiderivative, 1, a unique one, will be this. Based on the initial condition. So what is the rule for this? Which is the power rule. You may already figured it out. So let me give you the power rule. So when we want to get an answer of x to the nth power, we will differentiate x to the nth plus first over n plus first. Of course, I can insert here a constant c, doesn't matter. Because we bring down n plus 1, we simplify n plus 1, we subtract 1 from the power, and we get this. So, of course, if I have a function, f of x equals 3x to the fourth, what will be the most general antiderivative? Notice that if this is given as lowercase f, the antiderivative is given or has to be denoted by uppercase f. If this is g of x, this will be g of x, and so on and so forth. So, can anyone give us the most general antiderivative for this function? In other words, a family of functions, and all of these have the same derivative. Which one? This. Can anyone give us an idea?
3/4 x to the 5th.
So it's 3 x to the 5th over 5 plus a constant c. Always these have to be the same power. We increase the power by 1 and we divide by the same number. So then the final simplified form, you can keep it as is, or 3/5 x to the 5th plus a constant c. Can I check? Of course. You can. If we differentiate this, we bring 5 down, we simplify with 5, subtract 1 from the power, differentiate c and get 0, and we get that. Any questions? Okay, so I'm going to share my screen and open the floor for problems. I'm sharing, and this is the last section of chapter 4. It's 4.9. Let's choose. So we're adding a concept to the derivative, differential, and antiderivative. And now we are looking at the antiderivative. Okay, so from 5 to 26.
What does it mean by the most general antiderivative?
It's a family of functions. It's a family of functions, not just one specific, a unique function. All possible functions whose derivative is the given function. Infinite.
Okay, so if it's asking for the general derivative, then the antiderivative, then it has to have.
Yes.
It has to have the c.
Yes, mandatory.
Some variable.
Because this is not a variable.
Yeah.
The variable is only one, is x.
Yeah.
This is a constant.
Yeah.
And it can be anywhere
that
between negative infinity to infinity.
And it'll like, I guess it makes sense because it'll differentiate out.
Of course.
0.
Of course.
Yeah.
But it doesn't mean that you only get the same function, right? You have infinitely many functions whose derivative is x cubed.
Yeah, that makes sense.
Perfect. If you have other questions, always stop me, please. Okay, so maybe we should start. With a simple situation. Let's say I like this one. G of x, negative 1 over x squared. So if g of x equals negative 1 over x squared, let's find the most general antiderivative, uppercase g of x. Can anyone give it a try? Which function prime, and we discussed that many, many times, which function prime is negative 1 over x squared?
Is it 1
over x?
Excellent, brilliant, because we discussed this and this is very important. Thank you so much. Thank you so much. Awesome. Good. The basic functions we really need to know. If it's something sophisticated, we can use tables, we can so on and so forth. But the basic functions have to be known. What about this one?
Could you go
yes?
through, sorry, could you go through the negative 1 over x squared with the formula?
Yes. It's negative 1 over x, so it's x to negative 2. I don't want to, because that's exactly what I'm trying to avoid. Okay, so negative x to negative 2. So from here you have negative x to negative 2 plus 1, which is negative 1, divided by negative 2 plus 1, which is negative 1. You have to have the same number. These two will go away, and you will get the 1 over x plus c.
Okay, awesome, thanks.
But this is a formula that we should always have in the back of our minds. Now, if the power, yes, if the power is 3 here, it's a different story. But this is one specific one that I was begging for a couple of months already, almost, for you to remember. Because it's a waste of time to apply this for negative or for 1 over x squared or negative 1 over x squared. It's okay.
Yeah, that makes sense. I just wanted to see it. I just wanted to see the application.
But you saw the other one, right? You saw it in the other direction. 1 over x prime equals negative 1 over x squared. And now we're just going backwards.
Yep.
Perfect. Awesome. So also I would like to look at this, that r of theta equals secant squared. So r of theta equals secant squared theta. R of theta will be the antiderivative. Can anyone give us the antiderivative of secant squared? Which function prime is secant squared?
Tangent of theta.
Of course, that's it. And this is the most general because you will have infinitely many functions with the same derivative. Okay. So back to any problem. This looks weird, so let's look at it. And then I'll let you choose. I keep saying that I let you choose, and I don't. 4x to negative 2/3 minus 2x to 5/3. This is not a friendly situation. And we don't have really rules other than the power rule, right, for this. We cannot quickly determine that. So the uppercase G is 4. X, I'm going to write this out for the first or maybe 1 or 2 problems, but then we're going to have to calculate this without writing it. Negative 2/3 plus 1 over the exact same number. You don't have to perform other calculations. Minus 2. X to 5/3 plus 1 over 5/3 plus 1, and of course plus a constant C. Negative 2/3 plus 1 is 1/3. And I have 1/3 here, and I have to flip it. So this will be 12. X to 1/3. 5/3 plus 1 will be 8/3. And I flip it. So minus 6/8. And x to 8/3, correct. And that's it. You don't have to do anything else. Now, I know it gets confusing at some point in time, right? That's why I slowly ask you, what function prime is this? Because we are not differentiating this to get that. I know it can get confusing. We're asking ourselves which function prime is this. Now, if you want to check, if you differentiate this, we will get that for sure. So I bring down 1/3, I get the 4, and I subtract 1 from the power, and I get negative 2/3. Right? I bring 8/3 here, so I get the 2. And then from 8/3, I subtract 1, and I get 5/3. I differentiate C, and I get 0. So again, we're not asked to differentiate. We're asked to, we check using differentiation, right? So in order to make sure that this is indeed the function whose derivative is this, I will go now and differentiate to get that. If I differentiate and I don't get that, this is the incorrect antiderivative. Okay, so please try not to get confused.